Welcome, everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to use the ASA and AAS postulate to prove that two triangles are congruent. How are we learning it? Through the ASA and AAS congruence notes and the ASA and AAS congruence assignment. When can we use this information? To group items together based on limited but similar information. How do you know you learned it? By getting a score of 4 on the ASA and AAS congruence assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the ASA and AAS congruence notes, and I'll give you time to complete the ASA and AAS congruence assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your before you go. Your only homework for tonight is continue working on the Triangle Congruence Study Guide and any incomplete assignments that you may have. Let's take a look now at the ASA and AAS congruence notes. The notes begin with the learning goals and success criteria. Now, understanding congruence. In order to show that two triangles are congruent, we must show that all the sides and all the angles are congruent. So first we need to state the parts that are congruent. Well, we have AB here with a single dash, and we have DE here with a single dash, so those are congruent. Now notice, I said AB is congruent to DE. I didn't say AB is congruent to ED, because that is not a true statement. In order to make a true statement, I need to follow along with the corresponding parts. So I went from the endpoint with the double arc to the endpoint with the 90-degree angle. So I need to do the same thing here. Endpoint with the double arc to the endpoint with the 90-degree angle. So it's AB is congruent to DE. Then we have BC here is congruent to EF, and AC is congruent to DF. So those show that all the parts are congruent. Then I have my angles. Angle ABC is congruent to angle DEF because they're both 90 degrees. They both have the box. Then I have angle ACB, so the single arc, is congruent to DFE, single arc as well. And then I'll do my double arc. So BAC is congruent to EDF, and those are congruent. So now we've shown that all the sides and all the angles are congruent, so therefore the triangles are congruent. So we can now say that triangle ABC is congruent to triangle DEF. Now once again, what if we don't have all the information? What if we know that two angles are congruent and a side is congruent, but we don't know anything else? Can we still prove that the triangles are congruent? So in this case, we could see that side AB is congruent to side DE. And then we could see that angle ABC is congruent to angle DEF. And then we have angle BAC is congruent to angle EDF. Now, does that mean that the triangles are congruent? In fact, it does. And it's because we use this theorem called the angle-side-angle theorem, or ASA congruence theorem. And the angle-side-angle congruence says that if we know two angles and the side between the two angles are congruent, then the triangles are congruent. So if you notice, we have an angle, a side, and an angle. Again, order matters. So we have the side that we know comes between the two angles that we know. So then let's restate what we know. Well, we know side AB is congruent to side DE. We know angle ABC is congruent to angle DEF. And we know angle BAC is congruent to angle EDF. So therefore, we have two angles and a side between them that are congruent, so we can use the ASA theorem to state that the triangles are congruent. So we can say triangle ABC is congruent to triangle DEF. Now, what if we know two angles and a side, but the side is not between them? Can we still prove that those are congruent then? So here we have angle, angle, and a side, or a side, angle, angle, however you want to look at it. So can we prove that those triangles are congruent? Well, first, let's state what we know. We know that angle ABC is congruent to angle DEF. We know that angle BAC is congruent to angle EDF. And we know that AC is congruent to DF. So does that mean that the triangles are congruent? Well, once again, in fact, it does. And it's by using this idea of angle side congruence. So this says that if we know two angles and then the side after those two angles, then we know that the triangles are congruent. So here we have angle ABC is congruent to angle DEF. We have angle BAC is congruent to angle EDF. And we have side AC is congruent to side DF. So we have two angles and the side that comes after them are all congruent. So therefore, we would say the triangles are congruent. Triangle ABC is congruent to triangle DEF using angle side. Now, what is a geometric proof? A geometric proof is a step-by-step explanation that uses definitions, properties, postulates, and previously learned theorems to draw a conclusion about a geometric statement. A geometric proof is typically done in a two-column proof with one column being the statements and the other being the reasons. So what do geometric proofs look like? They look like this. So we have a column here that represents our statements. This is what do we know? So these are the statements of we know this, we know that, and so on. Now the right side is the reasons, and that is the arguments for how we know that's to be true. This is an example of a geometric proof. So it says AB is congruent to DE, and we have our reason as given. Given information is the information that they told us. So whether it's a marking or they state it in words, whatever it is, the given information is stuff that we didn't have to figure out on our own. It was told to us. Then we have AC is congruent to DE, given. Angle BAC is congruent to angle EDF, given. And then the triangles are congruent. Notice all of this was given information, but this part we had to come up with on our own, the SAS theorem, to prove that those triangles are congruent. So we use the theorems and postulates to fill in the rest of it. Let's take a look now at the ASA and AAS Congruence assignment. The assignment begins with the learning goals and success criteria. If we scroll down, there's a link here to take us to the Desmos activity. Go ahead and click on that link, and it should take you to a page that looks like this. We'll go ahead and click Start the Activity. The activity begins with the learning goals and success criteria. We'll go ahead and click Next. Now, for this one, it says, which of the following theorems would be used to prove that the triangles are congruent? So you would decide between the SSS, SAS, ASA, and AAS theorems. And when you do that, I can click on one of these. And some of them, they might be able to use more than one. So let's say I think it's these two. I hit check it. It tells me to try again. Then I click that one and notice it tells me, great job, because I got it right. So you'll answer these until you get them correct. Then we'll click Next. Same thing here. Then we'll go to slide 4. A few more of these, so we're going to continue to answer those. Then on slide 5, we're going to solve some proofs. So we're given two triangles, and we need to fill in the proof. So we're given some information here, and we need to fill in the rest of the statement. So it says angle CAB is congruent to what? So we have angle CAB is congruent to angle FDE. So we're going to put in angle, I'm going to copy this, copy. So angle FDE. And how do we know that? Well, because of the little arcs in the corner. So that's given information. Then we have AB is congruent to DE. So we'll type in DE. And that is also given information because of the little dashes here. Then we have angle ABC. So ABC is congruent to angle DEF because of the double arcs. So we'll copy the angle symbol. And we'll put in DEF. And that's given information as well because of the double arcs in the corner. Then we can say that triangle BAC is congruent to triangle EDF. So we'll go ahead and put that as our answer, EDF. And how do we know that? Well, it's angle, side, angle. So we put angle, side, angle theorem. We hit check it, and we can see that all of our stuff matches up, so we did it correctly. And then you'll click Next and do the same thing on the next slide. And then when you're done with that, you'll go back to your Google form and click Next. This will take you to your before you go. Go ahead and fill out your before you go and then submit your work on Google Classroom.